Okay, so good morning, a new day, a new project. It's Sunday morning, beautiful weather. My God, it's gorgeous, but still cold. It's winter, still winter. Okay, guys, so I did that video last night about AB8685V, the amplifier. You saw that? Okay, so it's looking like I did everything wrong. So thanks to a couple of guys here, and Jimmy, thank you so much. Also Brian Chick, yeah, and of course Daniel from Germany. They told me that I did everything wrong. You know, I just put it upside down. So for this kind of an amplifier, you know, everything is the other way. So the output, in fact, is the antenna connection, and the input, it's the one goes to the gateway, or the miner in our case. So let me try to do all these things, and I got my nano VNA here. Let's connect all these pieces together. So this goes to the miner. I'm trying to use as less connectors as possible. So that's the reason why I'm doing this trick. And then output, power supply. Let me open. Okay, connect to device, 800 to 950, let's say, megahertz. Let me have a calibration. And first, let me have this through connection to have a clear idea about the gain level down here. We have to look at this display, all right? So we can see a very clear, let's say, minimum gain, 27.07. This is the gain. Now we have the attenuator in, and that's why we have this gain. So let's remember that. Let's write it down somewhere. Let me check the power supply. This is 5.6 volts. Perfect. Anyway, the amplifier's got all the protection, I may call it, inside there, so shouldn't be a problem. But beware, don't push it too much. 6 volts maximum. Okay, so we are now in RX mode. We see the green light here, yeah, and let's have a test. Nothing. I did it the wrong way. Why we need an attenuator? Because the signal is more than 0 dB, like we need for a safe nano VNA working. Okay, think so. So what's wrong? What's happening with this gap here? But we can see very clear that we have a maximum gain at 947, and exactly from 860 to 920 we have this gap. This is interesting. So the output of the amplifier goes to nano VNA, to channel 1. Once more. Yes, we are good now. So we have the minimum gain at 800 megahertz, let's say. Okay, let me go closer. Let me go 867 to 870 megahertz. Perfect. Minimum gain at this frequency here we have, let's go like this, 800. Let's call it 868. We have a minimum gain of minus 8695. And maximum almost the same. Okay. Now, let's have these cables through exactly on 868. And let me see the bypass. So, at this frequency, through connection here, it's minimum gain minus 30.834. Well, people, I don't know if I'm right, but it's looking very, very good. So at 868 megahertz, we have an amplification of, let's say, 30.8 minus 8 0.6, like 22 dB. This is more than they advertised. And this is very good. Very, very good. Back. Okay, so now let me see. The amplifier is back in place. There we go, -8. If we put down the voltage, do we still have the same? Let's wait a little bit for the voltage to drop. Yeah, absolutely the same. So now we got here 3.2 volts. So the RX amplification or gain, it's not dependable of the voltage. This is very clear. Okay, very nice done. What I'm trying to do now, let's go back to 5 volts. Now let me see, we have this gain and amplification for 868. Let me check some other frequency. Let's say, let me try 500 megahertz. You know, this is advertised for 868. Let's see what's happening if we lower the frequency to 500.01. Let's say. Well, it's looking pretty okay. It's -13, so I can say there is a kind of peak for 868. Now we have from 300 megahertz to 1.2 giga. Let's see. Once more. You know, here is not conclusive. That's why it's having this dip. And we have at 1.2 gigahertz, we have a maximum gain of 6.39. So it's looking like if we get the frequency up, we have better amplification. Okay, let's try 2 giga. Oh, not anymore. So we have a peak of amplification around 1.15 giga. So far, as I can see, there is no dedicated RX or filter or anything else for 868. So it's working pretty okay in between -10 dB from 640 dB, I mean 640 megahertz to 1500 or something, with a peak amplification at 1.15 gigahertz. Okay, that's about RX. Now, I need my radio and I want to push this little guy to amplify a TX frequency. A nano VNA is capable of sending CV signal. Just a simple RF signal. Okay. Like I said, same old trick. -2 dB. Okay. Maybe it's working. And here, let me have the frequency. And of course, 868 megahertz. Now, the radio clearly received this. No gain. Of course, we got a signal here. And yes, look here. This one is running on TX. I can see the blue light. Okay, this is so cool. And let me see if we can have a better TX power. Well, doesn't look like going up, no? But anyway, it's very nice. So we have a -60 with no antenna, of course. What about, maybe I should improvise a little antenna or something? Yeah, I can do that. Yes, yes, yes. Oh yeah, look there. But that's funny, when I'm plugging this little piece of wire, the TX is running out. Interesting. But why? Anyway, doesn't really matter. What I'm trying to observe here is, so we have a minus 61. Let me have the power off. Is it going off, the signal? No. So I'm afraid this signal here is straight from nano VNA. Okay, power on. Do we see a beacon? I have the blue LED running, so it's transmitting for sure. Maximum gain, maximum power. So maybe it's not enough gain. Okay. I'm the antenna now. It's working. This is very clear that it's working. That the X it's working. I don't have a proper antenna, that's why. But anyway, the blue LED it's on when I'm so we got the green and the blue one. So let's say we have like 55 dB, 55 dB minus, of course, at 860. Let's get another frequency. Let me have 500. Of course, I got to go here. Oh, no antenna. Well, what about this? It's even better. Minus 44. Yeah, we have a blue light there. Let's go 500. Okay. Of course, look there. 500 megahertz. It's working great. Minus 50. Okay. This time, minus 50. 300 megahertz. Yeah. We got 300. Look there. It's working. I'm not sure, but it's looking like we have a full range. You know what that means? We can buy that for any frequency. Look here. This is huge. 1G. Is it the amplifier? Of course it is the amplifier. I have harmonics. There's the amplifier. And it's working great on 1G. And we have minus 45, like up here, 868, 868 with 65, 868 with 65, down here somewhere. Okay, so we got something like this. Let's go to 500 again. And we have a 45. This is funny somehow. It's looking like this. We have better signal on 500 than on 868. We have a small one on 200, minus 75, like this, and back again, 868. A lot of harmonics. Is this the amplifier? Yes, that's the amplifier. You see, I'm taking the power off. And the best signal here on 868 is minus 60 dB. I don't know, what shall I say? I don't bet it's right, but at least we have a certitude that this amplifier is working on the X2, so this is great. Okay guys, so I think that's it for today. The amplifier, it's okay. I don't see any kind of filtering or any kind of, strictly tied to 868. At least after my experiments, I don't see anything I will buy some more and I'll give some more tests and we'll see if it's the way I'm thinking or not. But anyway, thank you for now. I hope it's useful and I'll be back soon with some other projects. Like, subscribe, push the button down there, and don't forget to have fun. Bye bye.